Hi everyone, it's Linnea Tucker. I've taught you guys how to graph nonlinear functions, and I've taught you how to do it the most basic, but kind of the long way, by doing this. Choosing your x values to plug into your function and going from -10 all the way to +10. And I've told you somewhere in there you're going to find your vertex for your quadratics and your absolute value functions, or the starting point for your square root functions. But wouldn't it be nice to find a pattern or a shortcut that gets you those points right away? Yeah, I got a little trick up my sleeve. So I'm prepared to share now. All right, here's a graph of the absolute, or graph of your basic quadratic function, y equals x squared. This is the parent function for all quadratics. Okay, I've got a vertex here at 0, 0. And if I pick my x values, substitute them in, you can see that I've got some y values here that don't fit on the graph. None of these fit on the graph until I get into this range right here. Okay, so I've done a lot of extra work here that I didn't need to do. Well, how do you find the x value of your vertex real fast? You do this. What x value would you put inside the parentheses here so that when you simplify, the number inside the parentheses is 0? Well, in this case, it would be 0. So 0 is the x value of your vertex. All right, let's try this again. Here I've got the quadratic y equals x squared plus 2. Look what happened here. Adding 2 at the end moved my vertex up 2. Here's my chart, or my list of ordered pairs that goes with the blue curve. My vertex, oh, you know, I wanted to point something else out to you also. You can find the vertex from your table. If you look for, do you see this here? That's your vertex. My y values repeat here, my y values repeat here, and they repeat here. They should, because these points reflect across your axis of symmetry. Your axis of symmetry being right through your vertex. Okay? If I've got one point that's 2 to the left of the axis of symmetry, there should be another point 2 to the right. And that happens the whole way through here. I guess that's just 1 point because that's 1 and -1. This is 2 to the right, that's 2 to the left. Okay? On this one here, here's my table, and I'm going to go through. That one doesn't fit. None of these fit until you get to right in here. So we did all that extra work for nothing. But do you see how these reflect? And those reflect. There's your vertex. What's the fast way of finding the x-coordinate of your vertex? What number has to go inside the parentheses there to make simplified form that number be 0 inside the parentheses? Well, yeah, it's got to be 0. That's how you find your vertex. Take a look at this one. Y equals x squared minus 1. Well, it's my parent function here in red moved down 1. Take a look at this. Let's see. My graphable region is from here down to +3. And if you look at these reflect, those reflect, these are the same. This one right here is my vertex. How do you find your vertex, the x value of your vertex? Make whatever's in the parentheses equal to 0. Well, in that case, x equals 0. When you find your vertex, you need 2 points. Pick x values that are 2 smaller than your vertex. Pick 2 x values that are bigger than your vertex. With quadratics, you need at least 5 points. Okay? We've seen this one before. Take a look at this one. This one didn't move up or down. This one moves left or right. Well, take a look at this, specifically that, and take a look at this. All right, make note of all of that. Here's our table. Graphable region. Here to here, here to here, here to here. Guess what? That's my vertex right here at -2. So if I look at the equation, how do I get that x of -2 real quick? What value would you put in for x here in the parentheses so that this whole thing equals 0? What plus 2 equals 0? Yeah, that's got to be -2. That's how you find the x value of your vertex. Once you find the x value of your vertex, you need 2 points that 2x values smaller and 2x values that are bigger. Take a look at this one. Look at the equation. Look at your vertex, or specifically the x value of your vertex. All right. Graphable region. This right here is your vertex. How do I find that x value of 1 real fast? Well, look and see what's inside those parentheses. What number would you put in for x so that when you subtract 1, you get 0? We want to make what's inside here equal to 0. That's the shortcut. Well, what minus 1 equals 0? That's got to be +1. That's how you find the x value of your vertex. Then you need 2 points that are smaller and 2x values that are bigger. You got to have 5 points. All right, here's your parent absolute value function. Absolute values are always in the shape of a V. Graphable region, look at this. I'm going to do V shapes here. Once again, they reflect across your axis of symmetry. Axis of symmetry runs right down the middle of your vertex. This right here is our vertex. What's the fast way to find your vertex? What's inside the absolute value bars? When it's simplified, what x value would you put in so that what's in the absolute value bar simplifies to 0? Well, in this case, it's 0. All right? If you do that, pick 2 or 3 x values smaller, 2 or 3 x values bigger, make your graph. How about this one? Yeah, what made this shift up by 2? Adding on 2 here. My vertex is still 0. What would you put inside the absolute value bars so that when you simplify, your total inside the absolute value bars is 0? Yeah, that's going to be 0. That's your vertex. See how this does? If you're making a table, you better see that on absolute value. What happens if I have absolute value of x then -1? Yeah, that shifts the whole thing down by 1. Shortcut to finding the x value vertex. What do you have to put in here so that when you simplify you get 0? Yeah, an x value of 0. That's our vertex. Do you see the reflection across the axis of symmetry? Okay. Let's try this one. Note, I've got x plus 2 inside the absolute value bars. Take a look at that. Take a look at that. Okay, look at the pattern. Here's my table. I see reflection right here. So this makes our vertex right there. There's our vertex. What's the trick? Look at what's inside the absolute value bars. What do you have to put in for x so that the whole thing inside the absolute value bar simplifies to 0? Yeah, that would have to be a -2. That's how you find the x value of your vertex. Pick 2 or 3 x values smaller, pick 2 or 3 x values bigger. How about on this one? Look at that. Look at this. Are you starting to see the patterns here? All right. Let's see here. This reflects across here. If I put in the absolute, let's see, can I go down a little farther? Yeah, if I put in 3, 3 minus 1 is 2. The absolute value of 2 is 2. All right, swirly thing. So I reflect across here. If I had a 4, absolute value of 4 minus 1 is 3, which equals 3. We're reflecting across here, so this is my vertex. Fast way to find the vertex? You have to make everything inside the absolute value bar simplify to 0. Well, that was ugly. Try that again. What do you have to put in for x so that when you subtract 1 you get 0? Well, that's an x value of 1. Pick a couple x values smaller, a couple of x values bigger. Graph all those points. Okay, square root function is a little bit different because we don't have symmetry. We don't have a line of symmetry. Here is your basic parent function for all square root functions. Here's the table. What I told you guys in class was you have to find the point where taking the absolute value of a negative number, which gives you an error, switches over to getting a square root that's actually a real number. Okay, that will be your starting point. Here's my starting point. The numbers I've highlighted in yellow are the ordered pairs that actually give you pretty answers, although you can graph 2. 2, 1.4, 2, here's 1, there's 1.5, here's 1.4. 3, 1.7, here's 3, here's 1, 1.5, that's 1.7. You can graph those, but it's not needed. You could graph 0, you could graph 1, 1, 4, 2, and 9, 3, and then connect with a line arrow at the end. Okay, trick to finding the x value of the vertex. What do you put in for x underneath the radical sign so that when you simplify you get 0? Oh yeah, that would be 0. That's the x value of your vertex. Look what happens here. Here's the square root of x plus 2. Adding 2, move your vertex up 2. How do you find the x value for your starting point? Yeah, what will make your radicand is the number under your radical sign, equal to 0? Well, yeah, that would be 0. Subtracting 1 at the end pushes your vertex down 1. Well, I call it a vertex. I don't know if that's called a vertex or not. What's the trick to finding the x value for that starting point? What would you have to put in for x so that when you simplify your radicand, you get 0? Yeah, that would be 0. Okay, what if I put x plus 2 all under the radical sign? Take a look at that. Take a look at this. Noticing any patterns now? Okay, what would I have to put in for x so that when I simplify my radicand here I get 0? Well, what plus 2 gives you 0? That's negative 2. Negative 2 is your starting point. Okay? And on this one, notice a pattern here. It's x minus 1. Look at the x value of your vertex or your starting point. Shortcut. How do you find that x value for your starting point? Well, what would you have to put in for x under the radical sign so that when you simplify you get 0? What minus 1 equals 0? That would be 1. So 1 gives you your starting point. Did you guys notice the patterns? It might help. That's definitely a help. That's my trick that I may or may not have taught you in class. So good luck with this.